Next, let's explore a powerful concept in Agoric called Exos, or long-lived upgradable objects. Exos allow you to create durable objects that can be upgraded over time without losing their state. This is particularly useful for developing applications that need to evolve and adapt while maintaining continuity. Exos are objects designed to have a long lifespan and the capability to be upgraded. They encapsulate both state and behavior, ensuring that changes to the object's code do not disrupt its existing state. This makes Exos ideal for building robust, maintainable applications. To create an Exo, you define a durable class. Durable classes are similar to regular classes, but they include mechanisms for preserving state across upgrades. Let's look at how to define a durable class. Take a look at this example. In this example, we define a new durable class counter using makeKind. This function creates a new kind of durable object, and the initial state is specified in the function provided. Here, we initialize the count to 0 and then increment it. Exos can be used in various scenarios, such as managing user sessions, maintaining asset registries, or handling game states in a decentralized application. Let's explore a practical example of an Exo in action. Take a moment to review this code before moving on. One of the key features of Exos is their ability to manage state using baggage. Baggage is a persistent storage mechanism that allows you to store and retrieve data efficiently. Baggage enables your durable objects to store data that remains intact across upgrades. This ensures that any state changes are preserved even if the object's code is modified. Take a look at this example. In this example, we use baggage to store user profile data. When we create a new user profile, we initialize the data in baggage. We can then retrieve and update this data as needed, ensuring it remains persistent across any upgrades to the user profile class. In summary, Exos are long-lived upgradable objects that help you build maintainable and robust applications. By defining durable classes and managing state with baggage, you can ensure your objects remain consistent and reliable over time. Next, we'll discuss the various components that make up an application in Agoric, focusing on vStorage and the UIKit component, which are essential for building user interfaces. Building on our understanding of Exos, let's delve deeper into the concept of baggage. Baggage plays a crucial state in management within Exos, ensuring your data remains persistent and consistent across upgrades. Baggage is a persistent storage mechanism that allows Exos to store and manage state efficiently. Think of it as a way to keep track of all the important data that your Exo needs to function, even as its code evolves over time. With baggage, you can store any kind of data required by your Exo. This includes user information, asset details, or any other state that needs to be preserved. Baggage ensures that this state is maintained even if you upgrade the logic of your Exo. Let's take a look at a practical example where we use baggage to store and manage user preferences. This example demonstrates how to initialize, store, and update state using baggage. Take a look at this code example. In this example, we define a durable class called user preferences. We then use baggage to initialize and store user preferences such as theme and notification settings. We can then retrieve and update these preferences as needed. This ensures that user settings are preserved even if we change the underlying code of user preferences. Baggage can also handle more complex state management scenarios. For example, you might need to store hierarchical data or interrelated entities. Baggage's flexibility allows you to structure and manage such data efficiently. Take a look at the example on this slide. To make the most out of baggage, consider these best practices. Be sure to initialize state properly. Ensure that your state is initialized when you create an Exo. This avoids inconsistencies and ensures a smooth upgrade process. Be sure to keep state minimal. Store only essential data in baggage to maintain efficiency and performance. And finally, plan for upgrades. Design your state management with future upgrades in mind. This includes being mindful of how changes in your code might affect the stored state. In summary, baggage is a powerful tool for managing state in Exos. By understanding how to store and manage state efficiently, you can ensure your DApp remains robust and maintainable, even as it evolves. Now that we have a good understanding of Exos and how to manage state with baggage, let's talk about the process of preparing and upgrading these long-lived objects. Upgrading is crucial for maintaining and improving your DApp without disrupting its functionality. Before you upgrade an Exo, it's important to prepare properly to ensure a smooth transition. Here are the key steps you should take. Be sure to keep track of different versions of your Exo. This helps in managing upgrades and ensuring compatibility. Be sure to thoroughly test the new version of your Exo in a controlled environment to catch any issues before deployment. And finally, be sure to back up the current state of your Exo. This is crucial in case something goes wrong during the upgrade process. Once you are prepared, you can proceed with the upgrade process. These steps include deploying new code. Deploy the new version of your Exo's code. Then you can migrate state. Migrate the existing state to the new version and ensure that all necessary data transformations have been handled correctly. Finally, you can validate the upgrade by checking the integrity of the state and the functionality of the new version. To ensure a smooth upgrade process, consider using these best practices. First, minimize downtime. Plan the upgrade to minimize downtime for your users. And be sure to inform your users in advance about your upgrade schedule. Secondly, always have a rollback plan in case something goes wrong. This allows you to revert to the previous version without data loss. Finally, if possible, perform upgrades incrementally. This reduces the risk of major disruptions and makes it easier to isolate and fix issues. Let's look at a practical example where we upgrade a user profile Exo to include a new feature. This example will demonstrate the steps of deploying new code, migrating state, and validating the upgrade. Take a moment and review this example before moving on. In summary, upgrading Exos involves careful preparation, executing the upgrade process, and following best practices to ensure a smooth transition. By versioning, testing, and backing up state, you can upgrade your DApp's functionality without disrupting its operations. In the next section, we'll move on to discussing the various components that make up an application in Agoric. We'll focus on vStorage and the UI kit components, which are both essential for building great dApps.